At the very top of the notes, it goes through the multiplicities. Zeros, x-intercept, roots, all the same thing, right? Zeros, x-intercept, roots, interchangeable, meaning the same thing. We talked about that. I'm going to write it again to prove a point. Zero. No, I'm not. Until I press. Zeros, roots, x-intercepts, all mean the same thing. Okay? Now, how do I know there's two factors at somewhere? The factor is what? If I look at the factor, how do I know there's two factors that are the exact same? It's squared, right? If there's three factors that are the exact same, my factor's cubed, right? It's a giveaway with factors. True statement? So how I know a factor is squared? You literally square it. How do I know a factor is cubed? It's literally cubed, correct? But with zeros, with x-intercepts, if I write like x equals 7, you know there's an x-intercept there. But unless I carry on, you don't know how many are there that are of the exact same one, right? Like if I gave you x minus 2 squared on that last question, that last daily question, right? You'd say, oh, there's two factors there. Yeah. Do I have one of those papers? There's a chance that I do. There's also a chance that I do. I have still some stickers. I'm going to say no. I think I printed just than that. I'm going to say no. So, if we have x minus 2 squared, that means I have two factors there. True statement? We know that because it has the squared. There's going to be like a lapse. I don't know what I spoke about before this. It's going to sound really stupid to whoever watches this, but that's fine. But if I want to say x-intercept, my x-intercept will be at x equals 2. True statement? Because it's the opposite. We know how to solve that, right? And we'll say multiplicity, which you'll see it down here. Two. That's how you tell people that there's 2 there. It's an x-intercept. You have to write multiplicity 2. Multiplicity 2 is fancy for, hey, there's tangency there. Just fancy word for tangency. So you see here, it bounces. That means there's 2 there. And why does it bounce? Because for this one, there's 1. So I go up, I hit the x-intercept, and I'm like, carry on. This one, I come down, I hit the x-intercept, and I'm like, I want to carry on. And then it's like, no, psych, there's another one there. And you're like, oh, okay, I'll carry up. That's what happens. If there's 4 there, it just has like a battle. It's like, go down, go back up, go down, go back up. And then it's just a little wider at the base. If there's like 16 of them, it'd be like, no, yes, no, yes, no, yes, no, yes, no, yes, no, yes, yes, and then it would go up. Like it just makes it a wider base is all that happens when you have more of them. Okay? Challenge accepted. Go to your calculator. Y equals, and type in bracket x minus 2 to the 16. So just x minus 2 to the 16, press graph. What happens? Just wider, right? That's all that happens. So anything to an even exponent or an even multiplicity will create tangency, just a little wider of a tangency. It's like, hello, that, no, that, no, yeah, no, yeah, no, yeah, up. You know what I mean? So, any even multiplicity will get you a point of tangency. So we're going to write that. Even multiplicity. Sent you the memo. Now you got it. I swear I taught you whatever this is, because I had you till October. I'm sure you learned it.
After you left, my brain just kind of went off. I didn't.
You just left the building?
Yeah.
Oh, What happened? Okay, 0 multiplicity 3 is when you have a cubic, right? So here, it's going to create like an S shape. It's going to come through, and then it's going to be like, I want to go through, and then it's like, no, I want to go back down, and then it's like, no, I want to go back up, and then it does this. It like fights itself. It's like, I'm going to go straight. Oh, no, there's 2. I'm going to go down. Oh, no, there's 3, and I just carry on. What do you think is going to happen when there's 5? 5. When there's 5, what's going to happen? Same thing, but your S is going to be wider. Okay? Challenge accepted. I'm going to write it down this time because I think I lost people. Put into your Y equals X minus 2. 2, I need an odd something. What do I want it to be? 7? Cool. 85 is aggressive. I'm not going to put 85. So go X minus 2 to the 7. Can I have more factors too? Can I have like beside that an X plus 4 and an X minus 6? Yes. I'm just doing the smallest amount of factors I can have with 7. So this is odd multiplicities. Now in saying that, they'll often ask for the equation with the lowest degree so that you have the lowest multiplicity. Because if I have a cubic, if I have like this where it's making this S curve through, which is called a point of inflection, multiplicity 3 is a fancy way of saying there's a point of inflection. If I don't say smallest degree, you could literally put any odd factor on there, right? You could be like, it's at 2, so it's X minus 2, and I'm going to put 91, because you can. 1,365. Like, you can put whatever you wanted, right? It would be free and open to do whatever you willy-nilly wanted to do, right? They'd be like, do you see it that wide, though? Like, really? Really? Or why are you like that? That's what they'll think. So they'll say often smallest degree, so then it makes you have a 2 and a 3, right? If they say smallest degree, you have to pick a 2 if it's tangent. You have to pick a 3 if it's cubic. Then everyone's given the same answers, right? Okay. So that's information for here. So we're going to look at, for each graph of the polynomial function, determine. So we're going to determine the least possible degree. The least possible degree is based off of your x-intercepts, okay? This one has 1, because it goes straight through. How many does this one have? 2. So at the very minimum, it has to be what? 3. At the very minimum. You can't have like 3 x-intercepts and it be an x squared. You know an x squared has 2 x-intercepts at minimum, or at maximum, right? Goes through, or an x squared could have 1 where it bounces, or an x squared could have none. You guys learned that last year, right? So the least possible degree this baby can be is 3. And what the heck is the degree? It's the largest exponent. So this is an x cubed graph. That's the degree. The largest exponent is your degree. So if it's an x squared, it's a degree 2. If it's an x to the 4, like we just factored, that's degree 4. Okay? The sign of the leading coefficient. This is all going to help us for tomorrow when we do graphs. The sign of the leading coefficient, this here, is how it ends on the right. The sign of the leading coefficient is totally based off of how it ends on the right. Where is this one ending on the right? Up or down? Down. See that? It's negative. If it ended up on the right, positive. It's based on the right. Some people say, well, what about the left? Don't care. You know, it's based on the right. The left is something else, totally separate. X-intercepts. What are the x-intercepts here? X equals -4 and x equals 1. And if you stop there, you're wrong. What do we have to make sure we do? It's an x-intercept, so we have to say, can't do squared. That'd be a factor. Multiplicity. How many? 2. So we're doing the least possible degree. Because remember, if I didn't say least possible degree, you could say multiplicity 4, 6, 8, 10, 12, correct? You could put whatever multiplicity as long as it was even. Because this graph here has tangent. Tangent means an even multiplicity, right? So if I didn't put least possible degree behind here, you could tell me multiplicity 2, 4, 6, 8, 10, 12, multiplicity 1,000, if you really wanted to. It just has to be an even multiplicity. So this one here is x equals negative 4, and x equals 1, multiplicity. If it's tangent, what's the smallest multiplicity it can be? 2. Now here is the equation. The equation is really easy to come up with. It's also done the crappiest on the test. It's like people forget it exists, like how to make an equation. Often people don't do bad at questions on the test because they have no idea how to do them. Because they're like bad at it. It's because they like literally can't, they forgot to study it. It's like it's completely left the building. It was like, oh right, we did equation. I'm not studying it. All right? So the equation, how we did this in 20-1 is you always have to take your x-intercepts and work them back to what? X-intercepts and work them back to what? Starts with an F. Rhymes with actors. Factors. Yes. Because your equation, when we're done with it, is factors, 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 right? That's what the equation is. You typed both of them in. You just did this in a daily quiz. You typed the factored equation in. You typed the original equation in. Poof, they matched. Same graph. Yes? So if we want to do an equation, you are always going to go y equals a. And you always have to find this a, and people forget to find the a because the a is the vertical stretch factor, and the vertical stretch factor extends your y-intercept, but it doesn't actually change your x-intercepts. So you always have to look for an a. If there were something forgotten on an equation, it's this. People don't find the a. They write the factors down and solve. Well, they don't actually solve. They just write the factors down and think they're done. Now I look up here. It says I have an x-intercept at -4, correct? What is that as a factor? X plus 4. What about x equals -1 multiplicity 2? How do I represent that as a factor? X minus 1 squared. That's where people will mess up. They won't put the squared. If there's tangency, at minimum, you have to have a squared. Okay? How do I solve for a? Well, you pick a coordinate off of the graph. The greatest thing about diplomas is they'll often bold a coordinate. If there's ever a bolded coordinate on a graph, just one of them, it screams, that's your x and y, plug it in. Like, that's what it screams. Like, take me, plug me in. This is going to be 1. You know, like, they bold 1. So, if this was the graph on a test, I guarantee you on the diploma, they'll have something like this. They'll have this bolded. And then you're like, weird. This graph is here with one randomly bolded point. Why would they do that? Because they want you to use the randomly bolded point. If there's a one randomly bolded point, it's randomly bolded because they're like, use me. This is what use me, right? So what's this one at? 0, -4, which is my x and my y. So I'm going to plug that in for x and y to solve for my a. Okay? So I'm going to get -4 equals a, 0 plus 4, 0 minus 1 squared. So I get -4 equals a times 4 times 1. -4 equals 4a, and then I divide by 4. A equals -1. And then some people will box this and they're like, poof, answer's done. And I'm like, I asked you for an equation. You gave me a equals -1, although very nice. Lots of good work done. Did not give me an equation, right? So your last step after you find a is to plug it back in and just give me what it is. Y equals -1, x plus 4, x minus 1 squared. Now I have an equation. Now I'm done. True statement? Yeah.
There are no bolded points on the graph. You just pick any.
They'll bold one.
Oh.
Like I might not bold one, then you would pick one because maybe I screwed up. They will bold one because they don't want you trying to guess. Like, because if they don't bold it, they'll state it in the sentence structure. They'll say like this passes through 3, 4. That might be how they do it. Instead of bolding it, they might literally tell you what it is. But they have to, because if not, you're doing a sheer assumption that it's passing through there, right? So they'll bold something. Yeah. So here's one for you. This one has 1 at it. What does this one have? How many? 3, 5, 7, 9, 11, 13, 1001. 12,765,403. Like it just has to be an odd one, correct? Hence why the question states least possible degree, so it will be 3, right? We only have the option to put a 3 on there. Try that one out. This least possible degree is not the least possible degree of that x-intercept. It's the least possible degree of the entire graph. This one's 3, that one is not 3. This one has how many going through it? 1, and how many going through here? When you add those, you get good adding. Okay, now what's this one? How many are here? 1, how many are here? When you add those, you get? No, I said this is 3. This is the least possible degree of, like, just using the least possible degree. This has a multiplicity of 3. Not a degree of 3. A multiplicity of 3. Well, let's just discuss this one. So the least possible degree is the least possible degree of this graph. This graph has a least possible degree of 4, which means it's an x to the 4 graph. We're going to talk about the graphs more, which will make more sense, but I'm just kind of giving you an input information so that when we look at the graphs, they're not overwhelming. Because when I throw 5 graphs at you, you're like, what is going on? Okay? Won't be as bad. What's the sign of the leading coefficient on this one? Positive or negative? Because I only look at the right. And the right is up. If the right is up, the leading coefficient is positive. So this is a positive x4. Okay, x-intercepts. Where are my x-intercepts at? My arm's going to fall off. We're talking. -4 and it just hurts so bad from playing volleyball. -4 and 3. Do I just write 3? I write x equals 3. I'm going to write x equals -4. And then I write x equals 3. And if I write that, that means there's 2 x-intercepts. Yes? What do I need to write with the 3? Multiplicity 3. So when I go to write out my equation, I'm going to have y equals a. Every single time I have to find that. I put the a in, I'm going to have to find the a. X plus 4. X minus 3 cubed. 2 errors happen in equations. Forgetting the a completely, being like, don't need it. And then secondly, not putting the cubed or the squared when it's a multiplicity of 3 or multiplicity of 2. Do you see that could possibly be an oopsie? Forgetting to put the 3 or forgetting to put the 2? Cool, we need a point. Let's go back here. They would be like, hey, I'm going to make one up. Here. And then like they bold this and you're like, what is that? It's like, what's that garbage? I don't know. So if they don't bold something here and label it, we're all just guessing, correct? So on the diploma, they would bold it, and then they'd say, okay, well, this is actually at 0 and -11. Like, they'll bold it, and then they'll put the coordinates. And everyone has the same bolded point, and we're all finding the same thing, and it's not like willy-nilly guessing, right? Because someone could say, well, it looks like 10 to me, and the other's like, oh, it looks like -11. Well, now there's no option. This would be on the test, bolded 0 and -11. Okay? If there's a bolded point on the test and it's labeled and you're not using it, be suspicious. They don't put random crap on the test. Like, they don't bold a point and put the coordinate and then never use it. Like, you need to be suspicious. Like, well, I need to use this somewhere. Why am I not using it? Okay? They don't put any extra crap on math tests. They won't give you extra bolded points unless they expect you to use it. Okay? if it's labeled. That is not a y. So we're going to go negative 11 equals a, 0 plus 4, 0 minus 3 cubed. Get negative 11 equals a times 4 times 27. Negative 11 equals 27 times 4 is 108. Now we should catch ourselves if we screwed up. If I had messed up and I put it as not negative and I put it as positive, right? We're going to get an a that is going to actually be negative, but we just said that the leading coefficient is positive, right? Your a is your leading coefficient. So I divide by my 108, negative, and I get a equals 11 over 108, which is a wonderful a. I don't have the equation, so I still have to do it. 11 over 108, x plus 4, x minus 3. How should I catch my error? What's cool about getting equations of graphs? You can type it in and see if it's the graph that's in front of your face, so you know if you're right or you're wrong, correct? Like, you literally have a graph that's sitting in front of your face and an equation that should get you the graph that's sitting in front of your face. So your very last step for all of these should be plugging it into your calculator. So I want everyone to plug this in. Remember, you can use the fraction button by going alpha y equals enter. If you don't use the fraction button, you have to put this in brackets or your calculator won't know it's a fraction. Calculators know things are fractions by brackets or alpha y equals enter using the actual fraction button, okay? So everyone's typing into their y equals, and then I'm going to tell you something else you should do. Does everyone have it in their y equals? Have it in there? Okay, I go to my window and I change my window to match their window. Because sometimes you think that yours is wrong, only solely due to the fact that your window is not the same as their window. So I'm going to make my window the same. So the first thing you see is x minimum. What's my x minimum here? Nope, close. These are going by 2's. Negative 8. What's my x maximum? 8. What's my x scale? My x scale is what it's going up by. What's it going up by? 2's. So my x scale is 2. Okay, what's my y minimum? Keeping in mind these are going by what? 4. So this is negative 28, negative 32 is my y minimum. What's my y maximum? 16 then. What's this going to be? 20, because it goes up by 4. What's my y scale? 4. Then press graph, and they should look relatively similar. Now think about it. This is a nice actually square graph, and your screen is a rectangle. So they're not going to completely match, right? You have a square graph, and you're comparing it with a rectangle graph. But they'll look very similar, right? You can, if you have negative 10, 10, negative 10, 10, it's not as easy to compare because some of it's going off the screen, right? So what I do, I find my equation, I type it in, I go and adjust my window immediately to match the window that's up here, and they should look the same. If your graph is exactly the same but the wrong direction, I didn't put the negative 27 when I should have, right? And I'll catch my, oh crud, if my a value is the wrong direction, my leading coefficient, go back, try again. Because your leading coefficient tells you how it ends. Your a is your leading coefficient, right? It needs to be up, and I would have had it down. Does that make sense? Okay, we're going to give you a few questions for that to try. Here, hold on. both of these have one bullet where it says state where the intervals are positive or negative. We do not do that. That is not in our curriculum. Do not state where the intervals are positive or negative. So do everything else the question in number 4 and 10 asks, but do not state where the intervals are positive or negative. You will come to me and you'll be like, Lepp, I don't know how to state where, and I'll be like, you don't. That's what I do every single time. Okay? And then when I see it in the homework checks where people have the intervals are positive or negative, I'm very suspicious that you're a copier out of the backer book person. Because I don't want you to do it. What?